Yeah.
Okay, so uh, if you want to attend the math session, you can attend the math session for now. This is going to be solved with us. So
But I want to attend both.
want to attend both. Now it is not possible to move it.
Okay.
If possible, you can watch one session on YouTube and one you can attend. We are really sorry from our side. We didn't know there is another session at 6. Okay, so you can today solve with us. As you know, last class was not solve with us, it was open session. So today we are going to have solve with us for week 5. You can go to joinpd.com and use this code CXNFTZ to join the class. So all those people who haven't joined the session yet, please go to joinpd.com and use the code that you can see here on the right top corner of the screen, CXNFTZ, to start the class.
Ma'am, I have a question.
Yeah.
That ma'am, this week 6, the upcoming week, in the syllabus, it is mentioned refresher week. So it is refresher week, something like, or what is it was? Or
Okay.
it is.
Where it is mentioned? Website.
Uh, yeah, on the website where the.
Okay. From the website we have to change. Okay. Last time it was refresher week, but this time it is not refresher week. So you're going to get week 6 content you have already got, I guess.
Yeah,
So
uploaded.
the content is mostly multiple random variable, continuous multiple random variable.
Okay. And side by side, this for us, the math 2 sessions is also 6 to 8 today.
So what session is that one? That is also solved with this?
No, ma'am, I think Shubhaji sir's session. Notice it is concepts or something like that. He's explaining.
Okay. Okay.
So, ma'am, I don't know why it is for both subjects. Never it happened, but
Yeah, even
today
we
it is
had no
colliding.
idea. We had no idea that there is another session. We're not informed. So at the end, it couldn't be changed because tomorrow you have the deadline also.
Yeah.
So it just solve with us. If you want to attend the math session, if you feel that is that is more important for you right now, you can join the math session. One of the session you can watch it on YouTube.
Okay. Okay. Ma'am. Okay. Thank you.
Yeah. So we'll start. So this is the first question that we have here. So we have a continuous random variable x whose PDF is given as 3x square for x lying between 0 to 1 and 0 otherwise. Now, if you take another function y that is a function of x and it is x cube, then what should be the random variable, or what should be the PDF of the random variable y? There you have the options. Just first write down the question and then we can move to the option page.
Hi, I'm sorry to interrupt. In the link, it was written week 6 also. So, like, are we going to discuss week 6 as well or only week 5?
Where it is written week 6?
Like, when we see in the calendar, it's solved with us week 6 is written for stats 2.
Yes, ma'am.
So, that's the reason I was
It is
asking.
not week 6. It is week
We have
5.
discussed with sir in the last class, ma'am. That is, it will be a week 5.
It is week 5. It is
yeah,
week
2
5.
days ago we had a class. So we discussed
Yeah.
with sir to have a class today of week 5.
Yes, ma'am. It was well discussed and agreed, ma'am. We have not submitted the graded assignment for week 5. Then how can we discuss on it?
No, this is
Week
for
5
week
only.
5.
Yes,
Week
yes, I
5
know.
only.
I know. Yes, ma'am. I'm just explaining. This was discussed, ma'am.
Yeah, calendar. Just will check that. So you just let me know if you want to look at the option.
Hello, ma'am.
Ma'am, can you show the sample answers, ma'am?
Yeah.
Can you show the answer?
Hello, ma'am.
Yeah, options.
Excuse me, ma'am.
Yes.
Ma'am, we are doing this solve with us now, right
Solve with us for week 5.
now? Okay. Ma'am, how to join this?
You can go to joinpd.com and you see the code here at the right corner of the screen, CXNFTZ. Go to joinpd.com and use this code. You will see this page.
Okay.
Yeah.
Ma'am,
Yeah.
actually I'm not able to type the answer.
You have to select the option.
Actually, in the answer page, it is showing that no answers were configured for this question.
Same for me.
Oh, okay. Wait. Just give me a minute. Wait, I will stop sharing this. Or can you write the answer in the chat box for now? Just give me a minute. I will correct it. So in the chat box, I could see many people have written answer B as the answer.
I'm so sorry.
Yes,
What is
ma'am.
the question? Couldn't
But
ask.
in joint PD, we cannot write the answer.
Yeah, okay. Yeah, so can you just go there again and use this code RTU and WHR? Can you join again?
Where to join again?
Yeah. Use this code now, RTU WHR. Just check now if you are able to
Yes,
write the
ye-
answer.
Yes, ma'am.
Okay,
Yeah.
just write your answers there.
Yes, ma'am.
So I would request all those people who were there before in the previous join PD, please use the new one and write your response.
Can you guys go back and what is the question? And I was
Okay.
unable to. Okay.
The link you can go to joinpd.com and use the code RTUWHR. Use this code. Go to joinpd.com. Yeah, thanks. So we'll move to the solution for this question. See. Okay. So most of you have answered option B. See. So how do you find the PDF of a function of random variable? So we have two different options. Like if we can either find the CDF of y and then find the PDF of y, or we can directly find the PDF of y in case the function y is monotonic in the support of x. Okay, so if you look over this function y equal x cube, then in the support of y, sorry, in 0 comma 1, your x cube function is monotonic, right? All of you know how to draw the x cube function. Yeah, so in the support of x, that is 0 comma 1, it is monotonic. So when it is monotonic, we can directly use the monotonic differentiable function theorem and we can find the PDF of y. But in case it was not monotonic, then we could have find the CDF of y and then find the PDF of y. That would have been a little more difficult.
Ma'am, support of x is 0 to 1, right?
Support of x is 0 to 1, right? So let's see here. So what does the monotonic differentiable function theorem says? It says if your function g, that in this case is y equal x cube, if this function is monotonic in the support of x, then the PDF of y, fy of y, is given by fx of j inverse y divided by g dash of j inverse y, right? So here in this case, our function gx is gx is x cube. And if I want to write x in terms of y, so that will become x equal y to the power 1 by 3. So g inverse y basically is y to the power 1 by 3. Now, in this formula, we found, yeah.
Is G inverse Y is inverse of X, right?
G inverse Y is,
Inverse function of the original function, right?
yeah, so in this case, it is, see, Gx is x cube, correct?
Yes. Sir.
And if we have written y equal x cube, then x can, you can write it as what? Y to the power 1 by 3.
It is
So
the inverse
basically,
function.
inverse function, yeah, yeah.
Can you use the whiteboard, please, ma'am?
Yeah. So G inverse phi you found. Now, if your Gx is defined as x cube, how do you find the differentiation? You have to differentiate it. So differentiation of x cube, if you differentiate x cube with respect to x, it becomes 3 times x square. Correct. Now, if we want to put this into this formula that we have here, then the denominator part, what does it become? It becomes g dash of y to the power 1 by 3, right? So any variable that you put, like if g dash of x is 3x of square, then g dash of y to the power 1 by 3 will become 3 of y to the power 2 by 3. Is this part clear to everybody? Why
Yes, ma'am.
g dash of g inverse y becomes 3y to the power 2 by 3? Is this clear?
And then
Yes.
in denominator, ma'am.
Yeah, in the denominator.
Yeah, when we are writing mod of G dash of G inverse Y, right?
Yeah.
So it means that we have to take derivative of inverse of the function, right?
Yes.
Take derivative.
So g dash of x is defined as
Yeah,
3x square. So x, like if you take x, then it becomes 3x square. Now, if you take in place of x, if you take y to the power 1 by 3, so this will become 3 of y to the power 1 by 3 whole square. So this becomes 3 into y to the power 2 by 3.
Ma'am, can you show those substitutions on whiteboard, please?
Yeah, okay. Okay. So our gx was x cube, okay, and fy of y, fy of y is 1 upon mod of g dash of g inverse y into fx of g inverse y. Okay. Now gx is x cube, then g dash of x, g dash of x becomes 3x square. Okay. Now let's say I'm taking x cube to be y, or just 3 of x. Then x becomes y to the power 1 by 3. And this is nothing but your g inverse of y. Now, if I want to substitute, if I want to solve this fy, then in the numerator, I will have fx of g inverse y. So g inverse y is y to the power 1 by 3. Okay. And mod of g dash of g inverse y. So g inverse y is nothing but y to the power 1 by 3. Now, what is g dash of x? G dash of x is 3x square. So g dash of y to the power 1 by 3 will become 3 times y to the power 1 by 3 whole square. So this becomes 3 times y to the power 2 by 3. And in the numerator, since fx was defined as, so how was fx defined? Anyone can somebody
3x square.
Okay, fx was defined as 3x square. Okay. So this will become 3 times y to the power 1 by 3 whole square, which is nothing but again 3 to the 3 into y to the power 2 by 3.
3.
Right? So both numerator and denominator you see it comes out to be same. So fi of y will be just 1. Yeah.
Just a small confusion, ma'am. Like
Uh-huh.
in denominator part, whenever we
Yeah.
are seeing g dash of something, so generally we understand that we are supposed to take first derivative of that function, right?
First derivative of that function.
Right.
Yeah.
So I was under the impression that g dash of g inverse y means I am supposed to take the derivative of y to the power 1 by 3. I was thinking in that way
okay.
that I am supposed to take derivative of y to the power 1 by 3.
Okay. So this y to the power 1 by 3 is nothing but just x, right?
Okay, so we are supposed to substitute that value here, right? We are not supposed to take the derivative of it.
We are not supposed to. Can you repeat?
We are not supposed to take derivative of y to the power 1 by 3, right? We are just supposed to substitute.
Yeah. You don't have to differentiate with respect to y. You have to differentiate with respect to x.
Okay. Got it.
Yeah.
Ma'am, if time permits, can we solve this problem through CDF route also, ma'am?
Can we solve the problem in?
Through CDF route also, like you said, na, that if it is monotonic, then only we
Okay.
can.
Yeah, okay. Yeah. That will. So let's go back to our next problem. So question number 2 says a passenger train arrives punctually at a station every 20 minutes. And each morning a passenger walks into the train station. X denote the time the passenger waits for the train from the time he reaches the train station. The probability density function of X. So X here is the amount of time passenger waits for the train from the time he reaches the train station. And that density function is defined by fx of x is 1 upon 20 if x lies between 0 to 20. Otherwise, it is 0. So what should be the expected value of y equal x cube?
Ma'am? Ma'am?
Yeah.
Ma'am, can you please show me the question number 1 because my internet got disconnected, please?
Okay. What do you want? Just the answer part?
Yeah, the answer part, the solution part actually. Means what you have solved, ma'am, that approach I want.
Okay, so I will show it after this problem. Okay, is it
Yes,
fine?
ma'am. Okay.
Ma'am, am I audible? Hello.
Yes, you're
Am I
audible.
audible?
Yeah, you're audible.
Ma'am, question one. This question doesn't look very different from plain vanilla questions we have been solving. Like given a PDF, just find GX, the PDF of GX. I mean, that's it, right?
Sorry, can you repeat?
What I'm trying to say, ma'am, this problem looks exactly same like the other ones that we have been solving, like given a PDF, like, and you just have to find the PDF of GX, right?
Yeah, right.
Okay.
Yeah.
Hello, ma'am. Hello, ma'am.
Yes.
Ma'am, after putting the answer, typing the answer, do we have to press enter or just we have to type the answer?
Just you have to type the answer.
Nothing else. It will be automatically
Yeah, right.
submitted.
Yeah.
Okay.
Ma'am, I'm not getting the answering location.
Location as in?
Where to put the answer? Now, the normal place it is not visible.
You're not getting entered the number.
Oh yeah, I get it right. Okay. Thank you.
Yeah.
Hello, ma'am.
Yeah.
Can you explain how to identify monotonic function? I am very confusing.
Okay, so that we had we can discuss at the end.
Okay.
Okay, so let's move with the solution part here.
Yes, ma'am.
So, okay, the PDF of X was given to us, right? And we had to find the expected value of y equal x cube. So how do you find the expectation of a random variable, of a function of random variable, basically?
X into fx we integrate from minus infinity to infinity.
Yeah, gx of fx of x dx.
Yeah, yes, ma'am.
Yeah.
GX,
So
GX
that
into
is how we
GX.
find the expected value of a function of random variable.
Yes.
So the same thing we will do here. Now the x was a random variable and x cube was a function of x. So if you have to find the expected value of gx, that is x cube, you will have to do integral of minus infinity to infinity x cube times fx of x dx. Fx of x was 1 upon 20 for x lying between 0 to 20. So we'll substitute here in place of fx of x, we'll substitute 1 upon 20, and the limit of integration will vary from 0 to 20. So once you integrate it, you will get the final answer to be 2000.
2000, yes, ma'am. Ma'am, one question. Ma'am, in this, while calculating the expected value, do we have to look for any distribution in this case? Means in the problem, if it is just as you shown, do we have to also worry about the distribution
No,
and
not,
then calculate
no,
the
you don't
expected
have
value?
to. Like there's a direct formula, like if you have to find the
Mhm.
expected value of a function of random variable, you can just do, if you have to find expectation, you do x time fx of x, right?
Yes.
Now, if you have to find expected value of function of random variable, you can just do gx of fx of x. Gx times fx of x. If it is
Yes, ma'am.
continuous, you integrate. If it is discrete, you you do the summation.
Summation, right? Okay.
Ma'am,
Yeah.
if in the same question, range could have been from -10 to 20, right?
Hmm.
Then are we supposed to integrate from -10 to 20 in that case?
Yes. Yes.
And
Minus 10 to 20.
minus 10 to 20, okay, that's clear.
Yeah.
And in case of finding the CDF of the same function, so then are we supposed to divide the problem into two parts, like from -10 to 0 and then from 0 to 20, or we could have integrated in one go itself?
Okay, if you have to find the CDF, so CDF is like if you have to find CDF of y, right?
Yes, this PDF,
So it
yes.
is going to be probability y less than equal to some small y. So
Yes.
y is nothing but x cube. So probability or x cube is less than equal to some small y. It means probability capital X is less than equal to y to the power 1 by 3. And that becomes CDF of x, a CDF of x at x y to the power 1 by 3. So you should know what is the CDF of x, and then you can find the CDF of y.
I have a
You
doubt
didn't get
here.
it? Yeah.
If it is an affine function like ax cube plus b, so in that case also we have to take the same thing, ma'am, g of x into f of
Yeah,
x.
because that is also a function of random variable x.
Ma'am, in that case, that b is a constant which will not matter, no, ma'am. Like it will not change. Like it will remain as it is.
It will remain as it is.
Okay.
Maybe like if it is x cube plus b or ax cube plus b, then what will change here? So in place of x cube, you will write ax cube plus b 1 by 20 dx. Then you separate the terms and then you integrate.
Okay, ma'am. Thank you, ma'am.
So, ma'am, in this we have to put the values of a and b and then substitute, or
you try it out. Just put in place of x cube, you put ax cube plus b.
but a and b are unknown.
A and b are unknown. But it is some constant that you know that it is some constant. So when you have a constant, how do you do the integration? All I hope you know the integration.
Yes, ma'am.
Yeah. And regarding how to find the CDF, we'll look at it at the end. Okay. Yeah. So let's finish
Ma'am,
the
can I ask
questions.
a question? Ma'am, can I ask a question?
Yeah, please.
Ma'am, regarding finding the expectation values in this manner, we are supposed to know integration by parts as well.
Integration by
Parts.
Integration by
Integration
parts.
by parts. Because
you don't need integration by part here, right? 1 by 20 is a constant. You can pull the constant out. You just have x cube.
I'm not talking about this. I'm talking about these types of problems in the quiz or somewhere.
Integration by parts generally we don't ask you. We don't like the aim here is not to check whether you know the integration or not. You should just know what should be the idea. Mostly integration by parts and all we don't ask you. It will be a simple integration. Yeah. Okay. Let's move to the next question. Okay. So again, you have a continuous random variable and the PDF is defined this way. So what should be the value of 2 times expected value of x? Okay, so how do you find the 2 times expected value of x?
Ma'am, first we calculated expected value of x.
Okay. By? How do you find
By
expected
using
value of
the
x?
integration 0 to 1
Mhm.
x times fx of x dx.
Yeah, right. So we find expected value of x
Hmm.
and then multiply it by 2 times.
Hmm.
So that will be your answer.
Yes.
So how many of you are getting 1.834?
I'm getting 1.84.
Ah,
I'm
okay.
getting 1.83, ma'am.
Ah, that's right.
Because
As
it
long
was
as it is
up to-
1.8, it is fine.
It was given up to 2 decimals. So
Yeah. So any problem in this question? Any
No.
doubt? No?
No.
Yeah, let's move to the next part. Okay, so instead of expectation, if you had to find the variance of 2x,
This is the answer.
Yes. So, how did you find the variance of y?
First of all, I calculated the expected value of y, which
Okay.
is integration 0 to 1, 2x
Okay.
times fx of x.
Yeah, right.
So I multiplied 2x with the equation and put the limits.
Yeah, that is fine.
Then
And then?
e of y square, then I calculated, which was 2x the whole square times fx of x, which is 4x square times fx of x.
Right. Yeah.
So variance of y is e of y square minus e of y the whole square.
Yeah, correct. So since we have to find the variance of y here, so variance of y is basically expected value of y square minus expected value of y whole square, right? So what is expected value of y square, or in place of x, it should be expected value of y. So expected value of y square, so y is defined as 2x. So expected value of y square will become 2 times. Here it has been done using the property of variance. So variance of y, we are going to find it by 4 times variance of x, right? And we are finding variance of x and then finding the variance of y. So I think it will be a little more simpler.
Yes. Minus sign, I think.
Sorry. Sorry, minus sign here.
Minus.
Yeah. So
2.6.
yeah, basically it's the integration. You should just know how to calculate, how to calculate the integration part.
Yes.
So any major doubt in this?
Answer is coming what?
Answer is coming as 2.64.
Okay, getting 6.5.
It's okay. That is okay. So you should know just the idea of like how do you find the variance.
Yes.
So what are the properties of variance and how do you find the variance?
Here it is written that from the previous problem we know that expected value of x is 0.916, right?
Previous problem we had. Next slide, okay. This slide.
Next one.
Okay.
The first line, yes. Here it is written that from the previous problem we know expected value of x is 0.916, right?
Okay, yeah.
But our previous problem, our answer is 1.83. No?
That was expected value of I think 2 plus x or 2x.
2x,
So previous problem was 2 times.
Yes,
yeah.
yes.
Right. So expected value of x was 0.9.
Yes.
Yeah. Okay.
Yes. Okay.
Okay. So should we move to the next problem?
Yes.
Okay, before we move, can you check if the options are configured? Are you able to see the options?
What, ma'am?
Are you able to see the options here?
Yes, ma'am.
Yes, ma'am.
Okay,
Yeah.
then fine. So this problem is from the discrete continuous random variable part. Let's try to solve this one. Now I could see only 9 responses here. So any doubt in this problem?
Yes, ma'am, unable to calculate.
Yeah, okay. So I'll just give a few more minutes, just try it out. Okay, shall we discuss the solution?
Yes, ma'am.
Yes, ma'am.
Let's see, most of you have answered option D. Okay. So the problem states that a person randomly chooses a battery from a store which has 30 batteries of type A and 70 batteries of type B. So in a store, you have two types of batteries, a battery of type A and of type B. And battery of type A is 30 and type B, we have 70 batteries. Their battery life of each of the different types are also exponentially distributed, where the average life is given. So the average life of the battery of type A is 3 years and the average life of battery of type B is 7 years. If you select a battery and whatever battery you have selected, if that lasts for 5 years, so what is the probability that the battery is of type A? So we have two different random variable here. So one is we have, let's say if I'm defining my random variable X as the type of battery, okay? So either it can be of A or B. Their probabilities I can find. Probability that the battery is, choose a battery and it is of type A, that will be 0.30, and if type B, it is going to be 0.70, right? Because total we have 70, total we have 100 batteries, combining A and B. Now, given a battery is of type A, right? So given A, let us define another random variable Y that gives you the battery life. Okay, so if so what is given to us here is, given A, Y is exponential distributed. So we can write, given X equal to A, Y is exponential distributed with average life of 3 years. So in case of exponential distribution, we know that if the parameter is lambda, if the parameter of a random variable is lambda, then its average is given by 1 upon lambda. So in this case, if the average life is given as 3 years and 7 years, then its parameter is going to be 1 upon 3 and 1 upon 7 for A and B respectively. Now we have information here is that given the batteries of type A, the battery life is exponentially distributed with the parameter 1 by 3, and given the battery is of type B, the battery life is going to be exponentially distributed with the average with the parameter 1 by 7. Now what we have to find here is, if the chosen battery lasts for 5 years, what is the probability that it is of type A? So probability that X equal to A given Y equal 5, right? So what we have defined here is, let's say if we have defined an indicator random variable X. So if the battery is of type A, then we will say X is taking the value 1, and failure as if the battery you select is of type A. And another random variable Y that denote the battery life of the chosen battery. So given the information, we know all this. Y given X equal 1 follows exponential 1 by 3, and Y given X equal to 0 follows exponential 1 by 7. Now, what we have to find is, what is the probability that what is the probability that, this is not what we have to find. What is the probability that battery is of type A, right? So what probability that X equal to 1 given Y equals 5? This is what we have to find. So that can be found using the product of conditional time marginal. So if it is should I write it somewhere else, or from the slide it is clear?
Ma'am, you can write it.
Yeah, I think that is better. Just a minute. So we had to find what is the probability that X equal 1 given Y equals 5. Right? So this is basically what is the probability that X equal 1 comma Y equal 5 divided by probability Y equal 5. Now in the numerator part, we can write this joint distribution as product of conditional time marginal. We have the information of distribution of Y given X equal to 1, right? Times this is going to be probability X equal 1 divided by probability Y equals 5. So this is going to be probability that Y is 5 given that probability Y equals 5 given that.
This is marginal of Y, ma'am. So total probability, I think.
Yeah, given X equal to 1 into probability X equal 1 plus probability Y equal 5 given X equal 1. X equal 0 to probability X equal to 0. Same thing we have done on the numerator, but that is just for X equal 1, right? Now, once you find this, we know that y given x equal 1 follows exponential distribution. This follows exponential distribution with parameter 1 by 3. And y given x equals 0 follows exponential distribution with parameter 1.7. And probability x equal 1 was, I guess, 0.3, and probability x equals 0 was 0.7. These all information we had. Now we just have to substitute these probabilities here. So if y given x equal to 1 of 5, this is going to be exponential distribution, right? So how do you write the PDF of exponential distribution?
Lambda into e to the power minus lambda x.
Lambda e to the power minus lambda x. So lambda is 1 by 3, e to the power minus lambda x. So x here is, in this case it is y.
Yeah, it
So
will
what
be
is
y.
y? It is 5, right? This times probability x equal to 1, that is 0.3. Now in the denominator part, you're just going to have this first term. So e to the power minus 5 by 3 times 0.3 plus 0.7 times 1 by 7 e to the power minus 5 by 7. So once you solve, like this becomes 0.1, 0.1, 0.1, 0.1. So it is minus 5 by 3 divided by e to the power minus 5 by 3 plus e to the power minus 5 by 7. So this is what you should get. Is it clear?
Ma'am,
Yeah.
y given x equal to 1 follows exponential distribution, right?
Exponential 1 by 3, yeah.
Correct. So based on that logic only, we are assuming that if y given x equal to 1, 5 will also follow exponential distribution, right?
Y given x equal
The
to
numerator
1.
part, the numerator part,
Okay, numerator part here.
Yeah, so based on that logic only, we are assuming that this will also follow exponential distribution.
Which one? The
Like,
whole thing.
Y given x equal to 1 follows exponential distribution, right?
Right. Huh?
Okay, so well, then it boils down to y given x equal to 1 of 5, right? So that also there we are taking y as 5, right? The value
No,
of
no,
y.
no. So, okay, I think we're getting confused here. So, it was written like distribution of y given x equal to 1 of 5. So, if I write something like this, so what does it mean? It means probability x equal 1
Yes.
given, not this. Probability y equal 5
comma x equal to 1
given x equal 1, right? This is what it means,
yes,
right?
yes.
Now this is right,
Conditional probability.
and we know that y given x equal to 1 follows exponential distribution with parameter 1 by 3. Okay, so this whole thing follows exponential distribution, correct? Now if a random variable follows an exponential distribution, let's say if I'm writing x follows exponential lambda, then what is the PDF of x that we write? We write this is equal to lambda e to the power minus lambda x.
Yes.
Now in place of x, we have y now. Y given x equal to 1. Now y follows exponential 1 by 3. Correct. So given x equal to 1, given x equal to 1, y follows exponential 1 by 3. So if I have to write the distribution of y, then I will write fi of y. This is for given x equal to 1. Okay. So this will be 1 by 3 e to the power minus y by 3. Now, in place of y, we have given, it is given that y is taking the value 5. So we'll just substitute y equal 5 here.
Yes, sir. Okay. Thank you. Got it. Yes.
Okay, yeah. Any other doubt from this problem? Any doubt from this problem? Anyone?
No.
No? Okay.
Ma'am, actually, sorry, I just it was a bit confusing. I just had one clarification.
Okay.
We are basically doing the same thing, right? It is the probability that type A takes the value 5 divided by the joint probability that both of them takes the value 5.
Yeah, right.
Okay, thank you.
So,
Ma'am,
okay.
can you explain the last step?
The last step. So the last step, what you can do is you can divide the numerator and denominator by e to the power minus 5 by 3. Once you do it, you will get 1 upon 1 plus e to the power minus 5 by 7 divided by e to the power minus 5 by 3. So you solve it and you will get e to the power 20 upon 21.
No, ma'am, sorry, didn't get you. This,
Okay.
this your e
Wait,
raised to power
I will
minus 5.
write it there only.
Yes.
So you had we had e to the power minus 5 by 3 divided by e to the power minus 5 by 3 plus e to the power minus 5 by 7, right?
Yes,
now you divide both numerator and denominator. So we are dividing the numerator by e to the minus 5 by 3 and denominator by e to the power minus 5 by 3. Okay. So numerator becomes 1. This is fine. And denominator becomes 1 plus e to the power minus 5 by 7 divided by e to the power minus 5 by 3. Correct. Now you can solve this, right? So this you can write it as e to the power minus 5 by 7 times e to the power 5 by 3.
Okay, 5 by 3.
So once you solve it, you will get 7, 3. So 15 minus 15 plus 35. So it becomes 20 upon 21. So e to the power 20 upon 21. Is it right? Is it clear?
Ma'am, it will be minus 25 by 21, right?
Minus 25 by 21. Okay.
Okay, sorry. You are
7.
adding. Okay.
It is 315 plus 35.
Yes, ma'am. Got it.
So 20 upon 21.
Okay.
Okay. Anything else?
Not in this question.
Sorry.
Not in this question. Not in
Okay.
this
Yeah.
question.
Okay. Sure. So this was the last problem for the session here. So what
I had asked for CDF
whoever
now.
had
Yes.
whatever doubts you had, I will just take it now.
Yes, I have
And
only
the first problem of this question I had asked.
Okay, first problem of this question.
Yeah, and ma'am, I want the approach through integration method, ma'am. Can you help me out with that, please?
This problem.
No. First one.
This one is
This is the first one.
Yes, ma'am. Yeah, I want the
this one?
approach through integration method, ma'am.
Integration method, you want to find the PDF.
Yeah.
Okay. So sure. Just give me a minute. I will share the screen.
Okay.
Okay. So we had fx of x to be 3x square for x lying between 0 to 1 and otherwise 0. Now we want to find the PDF of y was given to be x cube. Okay. And we want to find the PDF of y, fi of y. So to find this, first we'll have to find the CDF of y. Okay. So how do you find the CDF? So CDF is going to be fy of y is going to be probability that y is less than equal to y, right? This is the first step when you find the CDF. Now what is y, capital Y? It is defined as x cube.
X cube.
So this is going to be x cube less than equal to y. And this you can write it as probability that x is less than equal to y to the power 1 by 3. Okay.
Yes, ma'am.
And this is nothing but fx of y to the power 1 by 3. Now we will have to know what is the CDF of x, right? So how do you find the CDF of x? This is our PDF. If we have to find the CDF,
we will derivate it.
Integrate, ma'am.
We'll
Sorry,
integrate, ma'am. We'll integrate from 0 to 1.
Yeah,
Yeah.
0 to 1, 3x square.
So fx of x, right? So for x less than 0, for x
0.
less than 0, it is 0. Okay. For x greater than 1, then
It's
equal to 1, it is 1. Now what will happen if x lies between 0 to 1? Okay.
Yes.
So we know that fx of x is integral of PDF, right? I mean, if you integrate the probability density function, then you will get the CDF probability. So if you integrate fx dx, you will get what? This is 3x square dx. So x square dx becomes x cube by 3. So 3 and 3 will get cancelled out and you will have just x cube where x lies between 0 to 1. So this becomes just 1. So basically, yeah, it is just for x lying between 0 to 1, it is 1. Or we can say it is 1 otherwise. If x is less than 0, it is 0. Otherwise, it is 1. So from here directly we can say like fx of
one
x.
otherwise, how can you?
Okay, because see, for
So-
x greater than 1, it is 1, right? Now what we had to find is for x lying between 0 to 1, right? This is what we had to find. And once we found it, we got fx of x to be 1. So there is no need to write 1 2 times. We can just write, otherwise it is 1.
Okay.
Ma'am, here we are putting the value of x is y to the power 1 by 3, right?
Y to the power 1 by 3. Yeah.
Yes. So that will become 2 by 3, right?
2 by 3, where?
No, while integrating, ma'am, can you substitute the value, ma'am, please? While integrating top line, ma'am. Top
Okay,
line.
where do you want me to substitute?
0 to
Okay,
1, 0
see.
to-
So see,
That
you
was
had 3x,
PDF.
you had 3x square dx, right?
Yes, yes.
So once you integrate this, it becomes 3x cube by 3. And it lies between 0 to 1. So basically it is x cube 0 to 1, and this is nothing but 1 minus 0, and it becomes 1. So the CDF becomes 1 for x less than 0. For x less than 0, you have 1.
Ma'am, I'm extremely sorry. Somewhere I lost the connection. See, at the bottom, while we took probability of x less than equal to y to the power 1 by 3, right?
Yeah.
And
There.
then we wrote fx. Now it is becoming y to the power 1 by 3, right?
Yes,
so
right.
I was clear up to this point, and after that there was some error, and I am not able to connect up to that.
Okay. No. So we found.
While integrating now,
we came here is we came at the point where we have to find the CDF of x at the point y to the power 1 by 3.
Correct.
Right. So
yes.
At y to the power 1 by 3. Right. Now for this we need to know what is the CDF of x. So the CDF of x is coming out to be 1. So basically this figure, if this is your x and this is your fx of x. So for x less than 0, this is 0. Your CDF is 0. Otherwise, your CDF is 1.
Yes, ma'am.
Okay. So any y you take, okay, any x you take here, sorry, not y, any x you take, it will come out to be 1.
Yes.
Okay.
Right?
Yes, ma'am.
Ma'am, what is this answer for this question, ma'am?
I think answer was 1 only, I guess.
1. Yes.
So 1 if x is, so in this case, you have to find the CDF of y, right? So CDF of y, wait, this is your CDF, and we had to find the PDF.
PDF of y equals to some function was there.
Wait, the question was what is
PDF of random
PDF of y equals to x.
y equal, okay.
For finding CDF of x, we need to integrate from 0 to x, right?
0 to x, yes, you're correct. Mistake, yeah.
Question is find the PDF of the random.
Yeah. So my mistake here. There it should be. Yeah, thanks for that.
Okay.
So
okay.
it is 0 to x, right? Because we are finding the CDF, and this is for x lying between 0 to 1. For x lying between 0 to 1, we are finding the CDF, and it comes out to be
x cube.
So this will get cancelled out, and you will have just x cube.
Yes, ma'am.
No, ma'am, it will become x to the power 4, no, ma'am. No, x cube.
No, it will be x cube.
So to avoid confusion, we can just take some other random variable here.
U.
Let's write u here. U. So
okay, ma'am.
This becomes 3 u cube by 3, where u lies between 0 to x. So this becomes x cube minus 0. So this is x cube. So okay. This is wrong. Okay. So for x less than 0, we have 0. For x greater than 1, we had 1. And if x lies between 0 to 1, we have fx of CDF to be x cube. Now we have the CDF, and we have to find the PDF, right? So what is the PDF of y? So fy of y, this is you differentiate the CDF.
3x square.
So it becomes 3
x square.
No, we have to write it in terms of y. Okay, so fx of y by 3 first we have to write, right? So fx of x becomes x cube. So fx of y to the power 1 by 3 will become y to the power 1 by 3 cube, right? So this becomes y,
Right.
correct? Now fi of y will be differentiation of fi of y. So what is derivative of y? It is
1.
1, right? So dy upon dy. So this becomes 1. Any doubt in this?
Ma'am, can you show me the solution of this, please? Because I had missed it actually.
Solution of
This question.
you mean the slide I will share. You can check the solution. I will share the slides in the portal.
Yeah, ma'am. This one. Okay. Can share.
Yeah.
I had asked. I have two doubts, ma'am. I have two doubts, ma'am. Towards the end
Okay.
of the session, you can explain those two doubts.
Okay. Can you tell me now?
Yeah. The first one is related to activity question, ma'am. The first
Okay, not from this, sir.
No,
Okay.
not from this. This is clear,
Okay, AQ, yeah, tell me now.
Yeah, 1.3, ma'am.
AQ 1.3.
Means lecture number 1, question number 3. Activity 1, question number 3.
You mean week 5 only?
Yes, yes, week 5, ma'am.
Okay,
5.1. Okay.
5.1, question number 3.
Activity 5.1, question number 3. Yes.
Okay. And
the second one is something from the lecture, like while we are dividing the integration into two parts. So that's a minor doubt. Will take less than 1
integration in
minute
two
to
parts.
explain.
Okay.
Yeah. That is time slot 32. Lecture number 2, time slot 32. Timestamp, not time slot. Timestamp 32 minutes.
Can you just check this timestamp and tell me what
Yes.
doubt
Okay.
you have there?
Okay. So
Okay.
in the time
So
we can solve this one.
before we go to these problem, any confusion in what we just discussed?
No, ma'am.
Excuse me, ma'am. Hello.
Yeah. Yeah, just Rajiv, tell me.
Question number 4, 5.4.
5.4, question number 4. Okay.
No, I have a doubt.
Anything else?
Yes, ma'am.
Tell me.
5.2, ma'am. Question 3 and 5.
Question 3 and 5.
Hmm.
Okay, so we'll see all this problem now. So 5.1.
Should I tell that? What is the doubt, ma'am?
The
time slot 32, ma'am. Yes. Timestamp 32.
Just give me a minute.
Yeah, I'm telling you, it's a PDF is given, ma'am. Hello.
Just give me a minute. I will share it out. Yeah, tell me now.
Yes, ma'am. This PDF is given, right?
Okay.
Fx of x 1 minus mod x within the range
Fx
minus
of x 1 minus mod x.
within the range minus 1 less than
Okay.
equal to x less than equal to 1.
Okay.
Means minus 1 less than equal to x less than equal to 1, 0 otherwise, right?
Okay.
So we are supposed to find the CDF Ex and variance x. So Ex and variance x I'm clear. CDF of x I'm a little bit struggling.
Okay, this is from the lecture, right?
Yeah, lecture, ma'am. Yeah.
This is
So
lecture
these
number
are the only two doubts which I'm having.
5.2.
Yes. When we're writing somewhere, the screen is not visible, I think.
I have written it down.
Just a second. Yes. Yes. Now it's visible.
Are you confused with the part where we take one part as 1 minus x and the other as 1 plus x?
Okay, I will share the screen. Yeah, this problem, right?
Yeah, this one.
Yeah, okay. So the random variable
This one. Am I
x.
audible, ma'am?
Yes,
Yes,
we're
this one.
audible.
Sorry, because some technical
So
problem again.
the PDF is given to you. Okay.
Yes, ma'am.
So for x lying between -1 to 1, your PDF is defined as 1 minus mod x. Now let's split it into two parts. Okay. Let's split -1 to 0 and 0 to 1. Okay. So you know if x is negative, your mod will open with the negative x. Correct? So you know how to work with mod. Do you know that?
Ma'am, if by x is negative, mod will be positive, right? Mod of
So
minus x.
mod of x will open with minus of x. So it will become 1 plus x.
If my x is negative, my mod of x will be positive.
No, I'm saying if x lies between -1 to 0.
Yes, ma'am.
Right? Then this mod x, right? You look at this graph. This is the graph. So this mod x, this curve minus the straight line which is on the second quadrant. This is the graph of 1 plus x.
Okay.
Wait, I will write it, draw somewhere else. Okay. In this, okay, before we start, you had the problem in the CDF. So can you tell me where the problem you had?
Yes, one small doubt is that whenever I'm getting a range, like which starts from minus to plus, right? So am I supposed to divide into two parts every time? Like one it will be from -1 to 0, and the second one will be from 0 to plus. Am I supposed to do this in all the problems? Like
No,
here
okay.
the range is from minus to plus, right? So for every problem, am I supposed to integrate it into two parts, like from -1 to 0, and then from 0 to plus, like this? For every
here you have to do it because the function is changing. Otherwise, you would not have to do this.
Okay.
The function is changing, and that is why you will have to do it.
Okay. Otherwise,
So,
we are not supposed to do that.
Yeah, like from -1 to 0, you see that you have 1 plus x, and for 0 to 1, you see you have 1 minus x. So that is why if you do the integration, this will be different. Right? So we have to do it in parts. So like fx of x, right? So you have to find CDF of x, correct? We know x lies between in the interval -1 to 1. So for x less than -1, we are writing just it is going to be 0, and x greater than equal to 1, it will be 1. That we are sure about. Now what we don't know is what is the CDF going to be when x lies between -1 to 0 and when x lies between 0 to 1. Okay, because we have different function in these two interval, right? So when the x lies between -1 to 0, then in that case, this is 1 minus mod of u. Okay. So when x is negative, so it will open with the negative value. So this mod of u will take the value minus u. So that 1 minus u becomes 1 plus u. Right?
Sorry, ma'am, sorry to interrupt.
I'm
Ma'am,
coming
you
in,
said
ma'am.
mod of minus u is taking the negative value. But
Sorry?
ma'am, you
Mod
said
of?
mod of minus u is taking the negative value.
Yes.
But if we try to, means mod of minus any negative value will come out as answer as positive value, right?
Yes, yes. That will come out to be positive.
But what we are doing is we are taking the you're converting it in, I mean, like multiplying it by -1, right? If it's negative, we convert it into positive by multiplying it with just -1. Just think of it like that. And if it's positive, we are doing nothing to it and we subtract it as it is.
Okay.
Okay, just let me, I will.
Okay.
So what is happening here is like, how is the mod function defined? So if I write y equal mod x, right? So let's say x lies between minus infinity to infinity. Okay? If x is positive, this is your x and this is your y. So if x is positive, x is greater than 0, your y become x, correct? You know the mod function is this graph, right? So this is your y equal x and this is your y equal minus x. Correct? So for x, when x is taking the positive value, you are writing y is taking plus x. But when x is taking the negative value, right? You are writing when x is less than 0. When x is less than 0, your y is minus of x, actually. So this is how the mod function is defined. So that is why, like, if you are doing fx of x, right? Let's say for x lying between 0 to -1 to 0. So fx of x.
Let's take any value from -1 to 0, right?
Yeah, you take.
Yeah.
Yeah, it becomes 1 minus. It is 1 minus mod x dx, right? And since you take any value in this range, that is -1 to 0,
that will be negative.
Your x is always negative. X is
Right.
taking a negative value, not the positive value. So since x is taking the negative value, this becomes 1 minus of x. So this becomes 1 plus x.
Okay.
So we can make this u.
After that integration is clear now.
It is clear, right?
After this integration is clear, and
Okay.
can you come back to that slide again, ma'am?
Sorry?
Can you come back to that slide again? Is it possible
Okay.
for you to switch over? Is it possible for you to switch over?
Switch over to?
That slide which you were
Okay,
showing,
that slide, yeah, okay.
It's a slide.
Yes. So as you said, ma'am, that since graph is changing, that is the reason why we are taking it into two parts, right?
Huh.
So does it mean that does it mean that for every PDF given,
Like
first of all, we are
this
supposed
is
to draw the graph?
Like this is defined. No, not generally graph. I mean the function. Like this is the graph for your PDF. Okay. Now you know that in different intervals, in interval -1 to 0, your PDF is defined in some other way, and in 0 to 1, it is defined in some other way. Like the function is different.
Yes. That's what I'm saying. Without drawing the
Yeah.
graph, we will not able to clear. No? This will not.
Yeah, graph like helps a lot in like solving the problems.
Correct. So like this, we solve from -1 to 0. Similarly, we are solving from 0 to 1, right?
0 to 1, right?
Correct.
So if you do it from 0 to 1, so using the formula of CDF, fx of x will become again probability x less than equal to x. So before this 0, you also had -1 to 0. So you will have to add that probability and then find the CDF for the interval 0 to 1.
Okay.
So it is going to be 1 minus mod of u du minus 1 to 0.
And that is coming half because we are putting x as 0, right? In the long expression given above.
Yes, because it is for 0 to 1.
Yes, so we are putting x equal to 0 in the long expression, so it is becoming half, right?
Now for 0 to 1, you have 0 to x, and this will come out to be integral 0 to x 1 minus mu du. So it will become u minus u square by 2, right? So this is what has been written here, u minus u square by 2, where u lies between 0 to x. So finally, for 0 to 1, it comes out to be 1 by 2 plus x minus x square by 2.
Ma'am, for this, we are taking value 0, right? That means we are putting the value of x as 0 for first, -1 to 0.
-1 to 0, we are putting 0 where?
X is equals to 0 in the what we get previously, f of x.
Yes.
Okay.
Because that for that interval, you'll have to calculate the probability, because we are finding the CDF now.
Okay.
I'm done now.
That activity that other person asked, ma'am, 5.1.
I asked
activity question 1.
Yes,
okay.
1.4 I asked.
5.1, first one and second one also.
Yes, I asked only 5.
Yeah.
5.14. Yes, ma'am.
Ma'am, can you explain that?
That is my second doubt. Yes.
5.1.
First question, ma'am, as well as second question.
This one?
Four, yes.
Question number
This
4.
one, ma'am. This one also, ma'am.
Question number 2.
Question number 1, ma'am.
Okay, question number 1. So again, the PDF is given, that is 3x square, and you have to find the PDF of y equal x square. So you will use the same approach, like the way we had done the. You can either use the function like x square is monotonic in 0 to 1, correct? So we can simply use the monotonic differentiable function.
Yeah, we have done this, I think, today.
Yeah, we have done the same function, just a different y. Yeah, so
ma'am, it will become we have to differentiate d by dy of x square, no, ma'am?
Okay, can you try this one first?
Yeah, I tried, ma'am, but I'm not getting. That's what I'm asked. Actually.
So yeah,
I'm getting
the same problem we have discussed just now. That is why I'm saying, like, what we had is, like, we have PDF, the same PDF, and in place of y equal x square, we had y equal x cube. That was the only difference. So the same method, can you use it here? We had discussed 2 different methods. Anyone you try. So once you have understood that part, now you should try this problem. Can you try this one?
Okay, ma'am, that's what I tried, ma'am, actually by
no, did you try after we discussed
yes, ma'am, that's what I tried. I'm getting
so where are you getting stuck?
I'm getting 2 by 3 root y, ma'am. I'm not getting 3 by 2 root y. That is the answer.
3 by 2 root y, actually.
Yeah, I'm getting 2 by 3.
Maybe division problem.
Your g of x is x square.
So g of x is okay. G of x is 3x square.
G prime is 2x.
G of x is 3x square. G dash of x becomes 3x cube. Sorry.
No, G of x is
6x.
2x.
2x.
Okay, sorry. I'm looking at f(x) of x, right? So g of x is x square. So g dash of x becomes 2x, right? So our g inverse of y is nothing but y to the power 1 by 2.
Y to the power 1 by 2.
Now, if we do fx of y to the power 1 by 2 divided by g dash of y to the power 1 by 2 mod. So numerator part becomes 3y to the power 1 by 2 whole square. So it becomes 3 times y divided by g dash of g dash of y to the power 1 by 2. Okay, so this becomes 2 times
y to the power 1 by 2.
Y to the power 1 by 2. Right?
2 root y.
So 3 by 2 root y. So we are getting 3 by 2. Can you tell me how did you get 2 by 3? Maybe somewhere you have done something.
I did 1 divided by, I did something else. Means I did integration, ma'am. Through integration method I did.
Okay, so can you tell me what did you do there?
Integration of, first what I did, no, ma'am, p of y less than or equal to y. So it is
Okay.
x square less than or equal to y. X is less
Right.
than or equal to root y, ma'am.
Yes, right.
So that what I did, I integrated in the limits between 0 to 1 root y dy. Correct, no, ma'am?
You integrated between
0 to 1 root y dy.
0 to 1
root y dy.
Okay, so you got fx of root y, right?
Yes,
Now,
ma'am.
what is fx of capital Fx of x? Capital Fx of x is integral of 3x square. So that becomes just x cube.
Yeah,
Correct?
yes, ma'am. Yes, ma'am.
So
Yes, ma'am.
fx of x is x cube.
Yes, ma'am.
Huh?
Yeah.
Now, fx of y to the power 1 by 2. What will it become?
Oh, y raised to 3 by 2 it will become.
Y to the power 3 by 2.
Oh.
Right?
Mhm.
Now, if you differentiate this, it becomes 3 by 2.
Okay.
3 by 2, y to the power 1 by 2. Okay?
Yeah, yeah. I
Then just
understood.
be
now.
careful. Be careful.
Okay.
Ma'am, question number 4, ma'am.
Same activity.
Yes, ma'am. Yes. Yes, ma'am. Yes, ma'am.
Okay. You have to find the PDF of mod of x. Okay. X is uniform. Can somebody mute the YouTube thing? I could hear the noise.
Hello.
So x is uniform in -3 to 2. And you have to find the PDF of mod of x. Okay.
Ma'am, this is a continuation of the third question.
Can you mute who's there?
Voice is very low.
All right. So this is AQ 5.1, question number 4. Okay. So it was given that x is uniform in -3, 2. Okay. Now what is the PDF of y equal mod of x?
Ma'am, hello.
Can you mute?
Hello.
Ma'am, it's not the video. It's
not audible.
It's just that voice is really low.
Oh, okay.
Someone is asking. No.
Okay. Can you write your problem in the chat box? I couldn't understand what you said. So by the time we discuss this problem, please write the problem in the chat box. I will have a look. Okay, so in this case, x is x lies between -3 to 2, right? So x lies between -3 to 2, and we have mod x. So this is your y, this is your x. This is your 3. Okay. Now, what we had to find? We had to find CDF, is it, or PDF?
PDF.
PDF of y. Okay. Okay, so you can see over here that in the support of x, your y is not monotonic. Is it right?
Yes.
In the support of x, y is not monotonic. Right? So we cannot use the formula that we had for finding the PDF. It means fy of y equal fx of g inverse of y divided by mod of g dash of g inverse of y. So what we'll do is we will take different ranges of y. So you can see here that y belongs to 0 to 3. Right? We have to find the PDF of y. So we'll start with finding the CDF of y. We know that for y less than 0, correct? Your Fy of y will be 0. So we'll just write it here. Fy of y is going to be 0 for y less than 0. Now for y lying between 0 to 2. Okay. Then y lying between
How come it is 0, ma'am?
Sorry?
How come it is 0 for your y?
Y less than 0, why is it 0? You're asking?
See the graph, it's 0 to
Mod
look
x,
at-
right? Y is mod x, right?
Okay.
Yeah. So y defined as mod of x, right? So if you have to find the probability that is Fy of y, so you can see there is no such y for which is less than 0. So basically the probability is 0 for y less than 0. So we can just write it over here. Now for y lying between 0 to 2. Okay. Fy of y will be probability y less than equal to y. So y is what? Mod of x less than equal to y. Okay. So this is basically probability x lying between
Plus
y
y
to
minus y.
minus y. Right?
And we are doing this because we are giving the modality sign to y, small y, right? This probability that minus y less than x less than y. We are giving the modality sign to y.
I don't know what you mean by modality sign
I mean,
to y.
this mod
So
of
basically
x.
this is like if x is positive, you will write x is less than equal to y, and if x is negative, then you will write minus of x less than equal to y, and it will become x is greater than equal to minus of y. So combining both, you will have x lies between minus y to y.
Okay.
Right?
Sure.
So this is how we got this. Now, okay. So this is what? This is fx of y minus fx of minus y. Or also we can say, since also what we can do is we can just do the integration, that is fx of x dx minus y to y, right? So what is fx of x? Since x is uniform in minus 3 to 2, our fx of x is going to be 1 upon b minus a, 2 minus minus of 3. So 1 upon 5, correct? For x lying between minus 3 to 2, correct? Now you can see this minus y and y, it is going to lie between minus 3 to 2, correct? So fx of y, that is defined as 1 by 5. So minus y to y, 1 by 5 dx. So this become 1 by 5 y minus minus y, right? So this is y plus y, that is 2y by 5. So this is for y lying between 0 to 2. So this becomes
2y by 5.
2y by 5. Now what happens when y lying between 2 to 3? Correct? So when y lies between 2 to 3, you see it can go maximum till 2. And sorry, x can go maximum till 2. Let's see it here. So for y lying between 2 to 3, your Fy of y, that is probability y less than equal to y. So you will have to add this probability, right, to y by 5. So in
Yes, ma'am.
place, yeah. So
Yes, ma'am.
in place of this, it will become 0 to 2. Okay. So you will have 1 by 5 dx 0 to 2 plus integral 1 by 5 dx
2 to x.
from 2 to not
X.
2 to x. Not 2 to x. It will be again the same thing, but your x will lie between this minus y to 2 here. In place of y, you will have 2 because x cannot go beyond 2, right? Because this is what the support is. X cannot go beyond 2. So we cannot write that x lies between minus y to y. We'll have to write x lies between minus y to 2 because this is where x can go maximum. Is this clear? Y minus y to 2?
Yes.
Okay. So once we integrate, you will have to integrate from minus 5 to 2. So this will become how much? X by 5. So 2 by 5 plus x by 5 minus y 2. So this becomes 2 minus minus 5, that is 2 by 5 plus 5 plus 2 by 5. So it becomes 4 plus y by 5.
And but
Ma'am, may I ask a question?
Sorry, ma'am.
Yes.
Ma'am, the answer is 2
Question.
plus y by 5.
Ma'am, yeah, ma'am.
This
What I
is
was trying to ask is that the integration should, I think, be
this is what this
integration should
is
run between
this is
minus 1 to
CDF.
1.
We haven't found the PDF.
Yeah, I'm talking about CDF only. It's 2 plus
No,
y
no,
by
ma'am.
5.
What I'm trying to say is,
2 person are speaking at the same time. I couldn't understand. Okay, Anirbom, can you tell me what were you speaking?
yeah, ma'am. What I was trying to say is that while finding the CDF, what I was trying to say, ma'am, am I audible?
You're audible. Tell me.
Am I audible? Hello?
Yes, you're audible.
Yeah, ma'am. What I'm trying to say is to find the CDF between 2 and 3, I think the integration should run between minus y to 2 only, ma'am.
That is what that is why minus y to 2 only we have written.
No, he means to say, ma'am, you shouldn't plus this 0 to 2.
0 to.
Ma'am, that is not required, ma'am.
Not required, yes.
Because minus y to 2 is.
Okay, yes. That is already getting added. Yes. You are right.
Yes, ma'am. That was my same question. That why you added this 0 to 2.
Yes, right. Because here it is not required.
Yes, ma'am.
Okay, so we will get what? We will get
only 2 plus y by 5.
2 plus 5 by 5. Okay. So this is our PDF, CDF that we have found. Okay. Let's see. Okay, to find the PDF, we'll have to differentiate the CDF. So your Fi of y Fy of y will become two by 5 for y lying between 0 to 2. For 3 to 2, what it is? 2 plus 5 by 5. So it is 1 by 5. So 1 by 5. And for otherwise it is 0.
Ma'am, in this, can we also use the formula for uniform PDF?
Uniform PDF.
Which was 1 upon b minus a. The numerator
Fx
was.
of x 1 upon b minus a.
Can we directly use this formula? Because see, the PDF in that, if you are calculating for 0 to 2, the width is 2 and the total is 5. So if we can directly use that formula to get the PDF of y.
Or y lying between 0 to 2. Okay, you're saying 2 by 5. Okay, right. And for y lying between 2 to 3.
It is 1 by 5 because the width is 1.
This looks reasonable. I think we can do that.
With the formula also we can do. This is also right. But with the direct formula also we can calculate the PDF.
Yes, we can calculate it here.
Because it's uniform distribution.
Yeah, we can do that. Yeah.
Yes.
We solve the third question. Is it the same week AQ 5.1?
Which one?
Chat box. Somebody had put in the chat box.
Yeah, we calculated the CDF.
Oh, yes, we calculated the CDF. Same problem.
Same.
Same problem. Yes, Pradarshini. So we have also calculated the CDF. So I hope the third part is clear.
Ma'am, can I ask you a question?
Yeah. Can you repeat?
Yeah,
Hello?
ma'am. I had a question. Like, for instance, we are given. Hello, ma'am. Can you hear me? Hello?
Yes, I can hear you. Yeah.
Hello, ma'am. Can you hear me?
Yes, I can hear you.
Yeah, ma'am. What I'm trying to find out is that say we are given distribution function of a PDF of x, which is from -3 or say minus one value to plus one value that includes 0. And we are given function of x as y equal to log x or something like that. So exactly how do we handle the 0 point there? I mean, is this is this even a question that could be?
If we have in place of mod x, you're saying if we had
Exactly.
log of log function.
Yes. So here, what we like square and mod x, now we are clear as to where the limits are going to go, right, ma'am? Let's say we are given something like a log x and under about 0, that point, how do you do that? Or 1, for instance, sorry.
So first, if we have to find the PDF of a log function, then we know whether the log is monotonic or not in the support. That we can check, right? Hello.
Ma'am, in that case, I think, hello, ma'am.
Yeah.
Can you please also, like somebody else also mentioned, can you please share as to how to check if it's monotonic? That
How
would
to check
be
whether it is monotonic or not? So monotonic means in either increasing or
ma'am.
decreasing, right? If we say that the function should be monotonic. So monotonic means either it is increasing or it is decreasing. Okay. So let's say we have this graph. This is your x and this is your y. Now I draw y equal x. So can you look at the graph and tell me whether the function y is increasing or decreasing?
It is increasing.
It is increasing. So we'll say it is monotonic. Okay.
Yes, ma'am.
Now, if in place of y equal x, if I draw y equal x square, so can you tell me, so in this whole x, okay, so in the range of x, whether y is increasing or decreasing?
No, ma'am. It's not increasing.
So you can see that for minus infinity to 0, your function is decreasing, but as x approaches to infinity, your y is increasing, right? So it is neither increasing nor decreasing in this
Mixture.
In this range minus infinity to infinity. If x takes the value minus infinity to infinity, your y is neither increasing nor decreasing in that range. So we'll say this is not monotonic. But if I just restrict it to this first quadrant, let's say, okay, then in the interval 0 to infinity, your
Increasing.
function y equal x square is increasing.
Yes, ma'am.
In the range minus infinity to 0, your function y equal x square is decreasing. So if we are just talking about minus infinity to 0 and 0 to infinity, then in those ranges, your y is monotonic.
Yes,
right?
ma'am.
Now similarly, if I want to drive y equal x cube, okay, so
Yes.
this is your x, this is your y equal x cube. So can you tell me whether it is increasing or decreasing?
It's increasing.
It is an increasing function. Y equal x cube is an increasing function. So since it is an increasing function, you will say it is monotonic. So I hope you all have studied functions in Maths 1. Has it been covered, the monotonic part?
Yes, we have covered.
Monotonic part is covered, right?
Yes,
In differentiation, maybe. I'm sure you must have covered monotonic in differentiation.
Yes, ma'am.
So just check whether function is monotonic or not. Okay.
Yes.
Anything else?
So, ma'am, it would be useful. So, ma'am, would it be useful to remember certain graphs or curves of some common standard function like e to the power x?
Like the standard one, like y equal x, y equal x square, y equal x plus 1, y equal x. So something that is easier to plot, like y equal x e to the power x.
Okay, ma'am, another thing, like you showed that in the zone 0 to infinity, y equal to x square is in monotonic. Or for minus infinity to 0, it's like decreasing into monotonic.
Yeah.
So like if you are given y equal to x square, then can we like segregate those two parts?
Yes,
and talking strictly in terms of
yes. You can do it. I mean, if you want to find the PDF of this y equal x square, right? And if x is in the support of minus infinity to infinity, you can split into two parts and then find the PDF. That is all right.
And ma'am, if I may ask one more thing, ma'am, with regards to y equal to x square curve that you have drawn, can you just explain support with certain limits like minus infinity to 0, 0? Like where exactly how do I interpret the support? I'm kind of like bit weak on that part.
Okay, so this is your x and this is your y. Okay, I am saying my y is x square, and x is, you have some let's say x is a random variable. X is a random variable, and let's say it is, its PD of fx of x is something is defined here. Let's say something, let's say something in the form of x, and x lies between minus infinity to infinity. This is what we are saying. Okay. Zero otherwise. Now the support of x, so it is minus infinity to infinity. Now y equal x square. If you draw y equal x square in this minus infinity to infinity, so this is minus infinity and infinity, then we know that your y is neither increasing nor decreasing, right? Like for for interval minus infinity to 0, it is decreasing, and for the interval 0 to infinity, it is increasing.
Yes, yes. Got you.
But what happens at 0, madam? Can we actually use the two? Can we actually combine the two? Because at 0, it may be meaning something else, isn't it?
Since it is a continuous random variable, so it won't matter much.
Okay.
Yeah.
Okay.
So, ma'am, what is my support of x here?
So first we'll have to define a proper PDF. I don't know what should be the PDF here, but some random PDF. And only if you look at the PDF, I can tell you what is the support going to be. So to check whether the function is monotonic or not, you don't need the support. You just have to, given a function, let's say I'm giving y equal x. Can you just check if it is monotonic on whether it is increasing or not? If it is y equal x square, can you check whether it is increasing or decreasing?
And this one is monotonic. This one is monotonic, like y equal to x, right?
Yeah, but y equal x square is not monotonic,
Not monotonic, right?
Yes.
Right.
Yeah.
That's clear, ma'am. Like, but when it comes in combination, like say for example, please write it down, ma'am. Like x is a random variable, uniform random variable. From -3 to 1, right? From -3 to 1.
Okay.
And then say for example, we have been asked to find the PDF of x square.
Okay. So, okay, you draw this graph, okay, not this, okay. You draw this graph, and you know,
you can take fresh page.
yeah, okay, I'll just clear all this.
Ma'am, will you take my question after this explanation?
What was your question?
It was in 5.2.
5.2 question number?
3 and 5.
Yeah, I will take after this.
Okay.
So, it is y equal x square. Okay? This is a x, this is a y. Now, x lies between -3 to 1. Fine. And if you find the PDF of x, it will be 1 upon 1 minus 1 by 3. So it is 1 by 4. So this will be 1 by 4 basically, this point. Now if you have to find the PDF of y, so first, what should be the range of y? What should be the range of y?
Like if I square, then it is coming 1 to 9, but it will be 0 to 9. 0 to 9.
0 to 9, right?
0 to
Because
9.
x taking the value 0, it will be 0.
Yes, 0 to 9.
So the range is 0 to 9. I think this problem is in the lecture. That's it. Okay. This problem is in the lecture, right?
Yes.
Yeah. So can you tell me what is the doubt here? This has been done in the lecture. If you can tell me, it will be better.
Like ma'am, different values for 0 to 1 and then 1 to 9.
Y 0 to
1. Yeah. So a PDF is being calculated in two different parts. One is from 0 to 1 and then from 1 to 9.
Yes, right. So how do we split that? This is what you want to know?
Yes, ma'am. Yes.
Okay. So see, for if x is 0, we know that y is going to be 0. And when x is 1, it is going to be 1. So stuff is little. So it should be here. This is that off. Okay. Now, okay, we know that y lies between 0 to 9. Okay. If we have to find fy of y, then it is going to be for y less than 0, we know that it is 0. This is fine, right? Now, if y lie between anywhere between 0 to 1, just look at the graph here. So if y lie between anywhere between 0 to 1, you take any line here, any y, okay? Then your fy of y, that is probability y less than equal to y, and this is going to be probability that x is less than equal to y, sorry, x squared is less than equal to y. So this becomes probability x lies between minus of under root of y, x plus of under root of y, right? If you take any y in between 0 to 1. So do you have the doubt in why is 0 to 1 we have taken and why not 0 to 9?
Yes.
Yeah?
Why we are,
Okay.
yes, why we are taking in two parts.
Yeah. So why is we have taken 0 to 1 here is because see, if I've taken 0 to 1, right? And we know that at x equal to 0, y equals 0, and x equal 1, your y is going to be 1. But the moment x becomes greater than 1, okay, moment x becomes we don't have anything x greater than 1, x is restricted, which is minus 3 to 1. So we cannot take x greater than 1, so we'll go for x less than 0. Okay, so basically less than not 0, less than minus 1. So anything that lies between minus 1 to 1, it is going to be same. The range is going to be between 0 to 1. Only for minus 3 to 1, right? X lying between minus 3 to 1, we'll have to worry. Like the range for y will lie between 1 to 9. Like if you take x to be, let's say, minus 2, then y will become 4. If you take x to be 1.2, right? Then y will become 1.44. So only for x lying between minus 3 to minus 1, the range of y is going to lie between 1 to 9, right? Otherwise, for x lying between minus 1 to 1, for x lying between minus 1 to 1, your y is varying from 0 to 1.
Okay.
So when you find the CDF here, so your x will, like if y lies between 0 to 1, then this is what you have to basically find. Okay, but the moment I say y lying between 1 to 9, then you take any y between 1 to 9, right? Your x can maximum go till 1. The same as the previous one, where x can maximum go till 2. It couldn't go beyond 2. Is it getting cleared or something? Hello?
Yes, ma'am, I got that point that from -1 to 0, it is similar to 0 to +1, right? What you, hello, ma'am? Am I audible?
Yes.
Yes, what you were saying that from -1 to 0 is equivalent to 0 to 1, right?
Yes.
But that logic holds for other value also. No? Like if I take from -2 to 0, it will be as good as from 0 to 2.
Sorry,
So
if I take minus?
-2 to 0, -2 comma 0. So it will hold true for 0 to +2. The way we discussed that from -1 to 0 is equivalent to 1 to 0, right?
No, this will go from this will go till 4. 0 to 4.
0 to 4.
Yeah, 0 to 4. You go till 0 to 4. So why we just split into two part? Because once you do it, you are done. I mean, otherwise there are many things you can, many small interval you can take, but the PDF that will come out will be is going to be same in different intervals.
No, what I meant by saying that from -2 to 0 is same as 0 to +2, because if I square -2, I am getting 4. If I am square +2, I am getting 4, right?
Yes, yes.
So that was my logic, that I am getting the same value. No? So
Yeah, you're getting the same value. That is why you don't have to repeat the same thing.
So then we could have taken directly from 0 to 9. Sorry, it might be that I'm not getting at this point
No,
of time. So we can drop it.
0 to 9, why you couldn't take is because you see here, right? It was the same problem here. So why couldn't we take directly from 0 to 3 here? Did you get this part? Why didn't we take directly 0 to 3? Why we had to do 0 to 2 and then 2 to 3? Why did we do 0 to 2 and then 2 to 3 here?
Trying to figure it out.
Sorry?
Just trying to figure it out.
Okay. Just think about it.
Ma'am, in this problem, y equal to x square, since x runs from -3 to 1, so what will be the support of x here?
Okay, but you're
Ma'am,
talking
am I
about this
audible?
one. Yeah, you're talking
Yes,
about this
ma'am.
one. X is uniform
Yeah,
in
the
-3 to 1, right?
Yeah,
So
so what will be
in
the,
between -3 to 1, how is your fx defined? Fx of x?
it's uniform.
Yeah, so
1 by
fx
4.
of x is 1 by 4, right? 1 by 4 for any x lying between 1 to 3, right? So what is the support of x defined? Support of
-3 to
x.
1 is the,
Yeah, support of x is what? All those x for which fx of x is greater than 0.
Got it.
So what is the x here? What should be the support? -3 to 1, right?
It should be between -3 to 1. That's it. Okay.
Yeah. Okay, you got it.
Right. And ma'am, there's one thing. In this support range.
Yeah.
So we'll have to take the values corresponding the values map to y in this support range only, and then we have to break this support range as per as it's possible, right? This is what we are doing, isn't it? We are breaking this particular support range of x while integrating just to get the right values of y. Is this not what we are doing?
We are splitting the range to get the proper support. Is this what you're saying?
We are checking as to since
We are
yes, sir. For instance, from 1 to 9, like the y for values between 1 to 9, say 4, like x can get -2 or +2. Like +2 isn't allowed. So we have to like go for that particular. We have to look for that support range, whether that PDF, whether the distribution, the FX is actually existing or not. And accordingly, then we have to like visualize or integrate, like draw the graph that is, right?
Yeah, right. Like mostly you have to draw the graph and then like look at what all where all you can split.
No, what I'm trying to say here is yes, ma'am. Like we have to be careful about where our support is, and then like draw the graph accordingly. Like since like it's like analogous to saying probability can't be more than 1, and so support like we have to keep the graph within that support zone, right?
Yes, we have to keep the graph in the support, right?
Okay.
Okay, so we'll just discuss the other two problems. AQ 5.2, question number 3 and 5. Question number 3 and 5. Okay. Okay, so can you tell me the doubt here? I don't know what asked the problem.
He has dropped, man. He has dropped. He's not
Oh, he
joining
has
us.
dropped. Okay. Okay, then let's not discuss it. Okay, and anything else? So we, how was the exam? Quiz 1. How was the quiz 1?
That's good, man.
Quiz 1 was good. Okay.
Thank you for
Was it
keeping
easy?
Thank you.
Difficult?
No, thank you for keeping it relatively easy.
What?
Thank you for keeping it relatively easy.
Okay, it was easy. Sorry, I couldn't hear.
I said thank you for keeping it relatively easy.
Okay, it was easy, right? That's good. All right, so can we close the today's session?
Yes, ma'am.
Ma'am, I just only hope that quiz 2 won't be compensated in terms of difficulty.
You mean you want difficult or you want easy?
I hope quiz 2 won't be no. I'm saying quiz 2 won't be compensated in terms of difficulty.
Okay. Yeah.
In a simple words, he's saying that it should be in the same line.
Okay, yeah.
Absolutely, ma'am.
Okay.
Yes.
All right. Thank you all. Thank you for joining the
Now
session.
we have session on Saturday, ma'am, right? On Saturday.
We have a session on Saturday. Yes.
For week 6, that concept revision, right?
Yes. Yeah. Thank
Who
you all.
will be taking that session, ma'am? You?
No, Shrikant will be taking the session. Okay.
Thank you.
Thank you all.
Thank you, ma'am.
Yeah.
Thank you very much.
Thanks a lot.